Okay, in this video we're going to take a look at our U-try problems for volume and surface area of a sphere. So this says find the surface area. I know my surface area formula is 4 pi r squared, but they tell me the diameter of the sphere is 50. In order to find the radius, I just cut my diameter in half, so my radius will be 25. So I'll go ahead and plug that in. So I have surface area equals 4 pi 25 squared. I'm going to work in terms of pi, so I'm going to leave my answer in terms of pi for the moment and see how it goes. So first I'm going to square 25, which gives me 625, and then I can go ahead and multiply it by 4. That's going to give me my answer in terms of pi. So the surface area for this one is going to be 2,500 pi. But if it asks me to go ahead and give it in decimal form, I'm just going to take my 2,500 and multiply it by pi. On Desmos, you can just put in pi, and the pi will work out just fine. So if we round this to the nearest hundredth, we're going to get 7,853.98, and this would be feet squared. The surface area of a sphere is 36 pi meters squared. Find the radius. So here I know my surface area is written in terms of pi, like that. So I'm just filling that in, and I'm asked to find the radius. The first thing I'm going to do is get rid of my 4 pi's by division on both sides. My 4 pi's cancel out here. 36 divided by 4 is 9. My pi's cancel out. So I'm left with 9 is equal to r squared. To get rid of my square, I take the square root of both sides. My radius for this one will be 3. And it's meters with our units. Our next one is on volume. So we'll take a look at the volume of a sphere. Volume has the formula 4/3 pi r cubed to the third power. It says our radius is 7. So that's fine. I'm going to just go ahead and plug that in. And just make sure you're doing it to the third power. So when I type in 7 to the third power, it equals 343. So now I have 4/3 pi 343. I'm going to go ahead and multiply my 343 by 4/3 and see if I get a whole number. What did you get? So 343 times 4 is 1,372. And then when you divide it by 3, oh, I get a repeated decimal. So I'm going to leave it like this. So far my volume is going to be 1,372 pi over 3. Because it gives me that decimal, I'm going to just leave it like that if it asks me in terms of pi. If not, then I'm going to go ahead and get my approximate volume by just taking that amount and multiplying it by pi. We'll get approximately 1,436, rounded to the nearest hundredth, 7, 6, and this would be yards cubed. Find the radius of a sphere with volume, 91.95 meters cubed. So now we know the volume. I'm going to go ahead and plug that in. And we're asked to solve for the radius. So one thing we learned in algebra is that we can get rid of this fractional coefficient by multiplying by the reciprocal. And if I multiply by the reciprocal on one side, I must also do the same on the other side. So we're going to go ahead and do that. My 4/3 and my 3/4 would cancel out. And on the other side, I'm going to do 91.95 times 3. And divide it by 4. So far I have 68, and I'm going to write down all the digits. I'm not going to round anything at this point. I'm going to leave it as is. Equals r cubed. And then I'm going to have to take the cube root of this. Depending on what calculator you have, you probably can't do that. But what you can do is say this raised to the 1/3 power. That is the same thing as taking the cube root, raising it to the 1/3 power. So I'm going to go ahead and put that into my calculator. Use parentheses around the base, maybe, and then raise it up to the 1/3 power. And depending on what calculator you have, you might want to put the 1/3 in parentheses. One thing that we left out of our formula was pi. Somehow we forgot that there's a pi in this formula. So our formula is 4/3 pi r cubed. So let's go back a second. We can still multiply by the reciprocal. That looks fine. But then we're going to divide by pi on both sides to get rid of everything. So in my decimal form, I might leave it like that. So I have pi in there too. And then raise that value to the cube root. And we're going to get a radius of approximately, if I round it to the nearest hundredth, I'm going to end up with 2.8. And this will be meters. We'll take a look at some similar solids and how they work. Cylinder A is similar to cylinder B, which isn't shown. It has a scale factor of 1 to 2. Find the surface area and volume of B. So one thing I know is that my scale factor is 1 to 2. That's great. This is my cylinder A, that's the first cylinder, and then cylinder B isn't shown in my picture. I'm going to use my scale factor, and if I just square my scale factor, this is my scale factor now for the area. So if I'm asked to find the surface area, I'm going to set up a proportion with my new scale factor. And let's see, surface area for this shape was 150 pi. I'm going to go ahead and cross multiply and divide. And I'm going to actually just leave my answer in terms of pi. So I know whatever the bottom is, it also will be pi. So I can go ahead and cross multiply and divide. Say 150 multiplied by 4 divided by 1. We'll get the surface area of cylinder 2 to be 600 pi inches squared. To find the surface area, I'm going to go back to my original scale factor. And instead of squaring it, I'm going to cube it. This is going to give me a new scale factor for volume. So my new scale factor is 1 to 8. I'm going to go ahead and do the same proportion. I'm going to put 250 though up top. And we're going to have to figure out what the bottom is. We're multiplying 250 times 8 and dividing it by 1. We should get, for volume, a volume of 2,000 pi inches cubed. Let's take a look at this cone one. Cone A is similar to cone B, which is not shown. The scale factor of A to B is 5 to 2. So this is my first shape, and I don't know the second shape. Find the surface area and volume. So if my original scale factor is 5 to 2, I square it, and we'll get 25 over 4. This is for surface area. That's my new scale factor. Set up my proportion with, and this time they didn't leave it in terms of pi, they just calculated the full value. So we'll do that. Looks like they rounded to the nearest tenth. So in this case, we're going to do 2,356.2 times 4. Get a value. And then divide the whole thing by 25. My surface area of cone B will come out to 376.99 centimeters squared, if I rounded it to the nearest hundredth. We'll take a look at volume. Volume is going to be my original scale factor, 5 over 2, but now I cube it. 5 cubed is 125, 2 cubed is 8. Set up my formula with the volume. And we're going to cross multiply and divide as well. So we're going to have 7,450.9 times 8, but divided by 125. And this will give me my new volume of 476.86 if I round it to the nearest hundredth centimeters cubed for volume. There are 2 more U-tries using the similar solids. The solids are similar. Find the scale. The scale factor is 1 to 2, written in Roman numerals, 1 to 2. So if our scale factor is 1 to 2, if I'm asked, oh, I'm sorry, it says find the scale factor of shape 1 to shape 2. Just kidding. We don't know the scale factor. But you know what? They gave us the volumes, so we'll take a look at it that way. When I relate the volume of 1 to volume of the second shape, volume, remember, is found by cubing. So I'm just going to take the cube root of both. And these guys are perfect cubes, which is nice. I'll find my scale factor to be 2 to 5. Last one, the solids are similar. Find the scale factor. This is for surface area. So I have 192 over 108. You might want to simplify this to 16 over 9. And then if it's surface area, we're just taking the square root, which will give us a scale factor of 4 to 3.